MCQ 15 have us investigate the events that happen during the cardiac cycle. So we have both event 1 and 2, and we're looking at it occurring simultaneously. Now, most of the options that were given to us involve the valve. So the bicuspid valve at A is actually an area that is found between the left atrium and left ventricle. So while the bicuspid valve closes, this indicates that the left ventricle pressure is higher than the left atrium. And if it's higher than the left atrium, this signifies that we are undergoing a ventricular systole event. Now, simultaneously, because both the ventricles contract at the same time, it is fair to say that both the left ventricle as well as the right ventricle should be contracting. So A seems to be okay because of ventricular systole. The right ventricle, just like the left ventricle, should be contracting. Let's take a look at option B. Option B said that the left ventricle contracts, and again, because all the ventricles should contract at the same time, we're looking at a ventricular systole event. And for the ventricular systole event, the atrial is undergoing atrial diastole, whereby all of the atriums are actually relaxing. The four chambers of the heart cannot contract at the same time. So again, saying that the right atrium contracts is wrong. For part C here, the semilunar valve opens. Now the semilunar valve is a valve that is found between two areas. One of them which is found between the left ventricle and the aorta. The next set, the semilunar valve, is found between the right ventricle and the pulmonary artery. Now, in order for the semilunar valve to be open, it could be indicative that the left ventricle pressure is higher than the aorta, as well as the right ventricle pressure is higher than the pulmonary artery. So for the ventricles to be higher than the aortas and the pulmonary artery respectively, we are again looking at the ventricular systole event, whereby the ventricles should be contracting. And again, if the ventricles are contracting, the atrium cannot contract. The atrial should be undergoing a diastole event. So in this case here, for option C, the atrium contracting is once again wrong. Now for our final option, the tricuspid valve open. Tricuspid is found between the right atrium and ventricles. So for the tricuspid valve to open, we're looking for the right atrium pressure to be higher than the right ventricle. So this suggests that we're going through atrial systole, where the atrium contracts. The ventricles, on the other hand, cannot contract, so it should be undergoing ventricular diastole. So also, when the tricuspid valve opens, it is the same as saying that my left atrium pressure is higher than my left ventricle. So it's not just the tricuspid that opens, the bicuspid should also open as well. So option D is wrong. We're looking for option A as the answer. But prior to completion of this video, let's just draw a figurative image of the heart and the approximate location of the valve. So we're looking at the right side of the heart. I'll call this as the right atrium. So the valve that's found between the right atrium and the right ventricle, this could be seen as the tricuspid valve. So from the right ventricle, you will be sending deoxygenated blood out into the pulmonary artery. The valve that's found in the pulmonary artery is the semilunar valve. So the counterpart on the left side, you're going to have your left atrium and a slightly larger left ventricle, because the left ventricle have to pump blood towards the rest of the body. The valve between them is known as the bicuspid valve, and sending blood out via the aorta. Also between, we are also looking at the semilunar valve. Although this is anatomically not how the heart should look like, this open up structure here allows you to see the valve that's found between two areas, and how it's opening and closing is based off pressure difference. Again, just to reiterate, the answer for this question is